So let's see the next topic, that is impulse. So what is impulse? Now, okay, first of all, let's suppose, for an example, let's consider there is, okay, I don't know why do these examples come to my mind. Okay, so let's learn about impulse. For an example, suppose there is person, okay, who is standing on a very high building, okay, on the floor of very high building, on the terrace, and there is another person who pushes that person. So what happens? Person A falls down, okay, on the earth. Now he will fall down with very high velocity, right? He will fall down with very high velocity. And what happens when he falls down? All of a sudden, what happens? His velocity becomes zero. Okay, so suppose he falls with the velocity of 100 meters per second. Within fraction of second, it becomes zero, right? So now the force exerted by Earth on that person, we can't find it out, okay, because it happens very fast. What can we find out? We can find out the effect of that force. And what is the effect of that force? It is the change in momentum, okay, or we can say force multiplied by duration of the force. Okay, and this is known as impulse. But this is quite violent example. So let's consider another example which is not that violent. So for an example, you're playing cricket, okay, so there is a bowler, for an example, Shoaib Akhtar, okay, quite old bowler nowadays. Who can you consider from Pakistan? Mohammad Amir or somebody, if you know cricket, okay. So he's bowling at the speed of 150 kilometers per hour, and here we have a batsman, for an example, Virat Kohli. He just keeps his bat like this. So ball comes with the speed of 150 kilometers per hour, goes back with the speed of 150 kilometers per hour. The impact time is very small. Okay, the impact time is very small. The impact is very large. The ball comes with some momentum, it goes back with some momentum, same momentum we can say. Okay, so how much is change in momentum? P2 minus P1, it will be 2 times of P, right? So change in momentum is, if mass of ball, suppose it is 1 kg, then it's 150 kilogram meters per second times 2, okay, and it happens in fraction of second. So this kind of forces are known as impulsive forces. For these forces, we can't measure the impact time, but what can we measure? We can measure the impact of the force, okay, or the effect of force. It is known as the impulse. So we know F is equal to P2 minus P1 divided by T2 minus T1. So take T2 minus T1 on other side. Therefore, the impulse is defined as F multiplied by T2 minus T1, and it will be equal to P2 minus P1, right? So nowadays we have fast cameras, etc. Okay, in cricket they measure impact time nowadays, but earlier it was difficult. Okay, but this is just an example. There are many examples where we can't measure the impact. Impact time. Okay, and that's why this concept of impulse is important, right? So then, now if we think of a constant force, so in this example we considered a constant force, and if we draw force versus time graph, okay, so at time t1 the force was F or F naught, let's say. At time t2 also the force was same. Okay, so what is impulse? This force, the magnitude of force multiplied by t2 minus t1. So if you see it on the graph, what is this impulse? It is area under the force versus time curve, right? It is area under force versus time curve. I want impulse from t1 to t2. It is area under this curve from t1 to t2. And in this case, it is very simple. It's just a rectangle. So it is F multiplied by t2 minus t1. the length of this side will be T2 minus T1, right? Yes, no? Okay. But now, if we have a graph like this, then force is not constant. Okay. If we have a graph like this, force will not be a constant. So impulse will be equal to what? So force will be some function of time. And if we want area under this curve, so I can say area from this time to this time. This is small interval. So the small area will be equal to what? F of t times dt, right? This will be, okay, f of t times delta t or dt, let's say. It is area under this curve from here to here. If I want area under this curve from time t1 to t2, what will I have to do? I have to integrate this function from t1 to t2. Okay, so that will give me the impulse, right? So integral of f of t dt from t1 to t2 is impulse from t1 to t2, and it is always equal to p2 minus p1, final momentum minus the initial momentum. Is this thing clear? Okay. So this is a simple concept. There have been some questions based upon this thing. So let's see those questions. The force F acting on a particle of mass m is indicated by force time graph as shown. The change in momentum of the particle over time interval from 0 to 8 seconds is. So tell me, what should we do? We have to find area under the graph. But this is signed area, right? This is signed area. If we have something above x-axis, okay, this area will be positive. Below x-axis, it will be negative, right? This is integration, because here f is positive, x is positive, this will be positive. And here f is negative, x is positive, so this will be negative. Okay. If we consider on this side, oh, you found it out, right? Let's check. So area of this first triangle will be equal to half of, it is half of base into height. So base is 2 into height is 6, plus you have area of this thing, which will be minus 3 multiplied by 2. Okay. And plus you have area of this thing, which is 4 into 3. So this is 12, this is minus 6. So 12 minus 6, okay, is 6. And this is again 6, right? So 6 plus 6, 12 Newton seconds, right? Okay. So what was I saying? Let me complete it. Okay. Because we have 4 quadrants. So if we have something here, if force acts like this, okay, just for an example, force versus time graph. Graph is like this. Then okay, in in any case, actually, I'm sorry, in any case, okay, I mean, if you want to find out impulse, okay, in earlier cases we found the change in velocity, right? Change in velocity is, okay, we know acceleration is dv by dt. So change in velocity will be area under at curve. So in that case, okay, what will you consider of this area? Will it be positive or negative? This is origin. This is origin. So here you have this quantity is negative. This quantity is also negative. So if you are integrating, this area will be positive, right? If you have area on this side, so this quantity will be negative. This quantity is positive. So area will be what? Area will be negative. Okay. So it is like this. It is positive here, negative here, again positive here because both are negative. Negative times negative is positive and negative here. Right, got it? Yes, no? Okay, because we are considering integration. Okay, so it is signed area. So if this quantity is negative, this quantity is negative, negative times negative will give us positive in this quadrant. In this quadrant, this one is negative, this one is positive. So positive times negative will give us negative. Okay, like that, right? So there may or may not be a question based upon this thing. If there is a question, okay, it can be anything, right? It can be suppose work, okay, work done. So it is legitimate. So now time we don't take generally negative, but position we mark this one as 0. We can mark the positions towards left as negative. Okay. So work is force times displacement. So now if this is force versus displacement curve, okay, force versus position curve, then this work and this work, both of them will be positive. Yes, no? Please keep this in mind. Let's move on to the next. The force time graph for linear motion of a body initially at rest is shown in figure. The segments shown are circular. The linear momentum gained in 4 seconds. So where is 4 seconds? This is 0 to 4. So from here to here, how much will be the linear momentum gained? Tell me. The segments are circular, they are saying. So this is simple, right? This is okay, semicircle. So its area will be half of pi r square. Okay, and we want to consider from 0 to 4 only. If they had said from 0 to 8, then this is negative, this one is positive. So answer would be 0. But we want from 0 to 4 only. So that is half of pi multiplied by how much is r? R is 2, right? So it is 2 square. So 2 square is 4, 4 by 2, okay? That is, sorry, 2 pi. Okay, 4 by 2 is 2, 2 times pi. 2 pi Newton second would be the answer, right? Okay. Let's see next one. So in this case, we have to find just areas, okay? So a particle of mass 2 kg is initially at rest. A force acts on it whose magnitude changes with time. The force time graph is shown below. Okay. The velocity of the particle after 10 seconds is. So first let's find out change in momentum. Then we can find out the velocity. Okay. So P2 minus P1 will be equal to how much? Total area under this graph. So it is half of base into height for this first triangle, right? It is half of 2 times 10 plus you have a rectangle. So it is 2 times 4 minus 2 is 2, 2 times 10. Okay. Plus you have, what is this thing called? Trapezium. What is the area of trapezium? half of height into parallel distance. Then what will be the height? This one or this one? So it is half of the height. Yeah, base you can say, or if trapezium is drawn like this, then you can say this is height. Okay, so let's call this as h. So it is half h multiplied by sum of two parallel sides, this one plus this one. Okay, let's call this a, this is b. So formula for area of trapezium is half of h multiplied by a plus b. Okay, right. So we need to remember the formula also for regular areas. Otherwise, it's okay. Otherwise, we can't solve, right? So it is half h multiplied by a plus b. So a is 10, b is 20. Okay, and h is 2. So half of 2 times 10 plus 20. This is the area. And last one is simple. Half of base into height. So half of 10 minus 6 is 4. Okay, base is 4, height is 20. So yes, what is the answer of all this? This is 10, this is 20, 10 plus 20 plus this is 30 plus I'm sorry, 80, 130, 140, sorry, not 130, 140. Okay. So then mass is 2 kg. Initially it is at rest. Okay, so P1 is 0 because initially it is at rest. It is m times v, and m is 2, so v will be equal to how much? 140 divided by 2, that's 75. Yeah, 70. Sorry, 70. Oh, but then did I miss something? To check. This is 10, this is 20. Okay, this is 10 plus 20 is 30. First one is how much? 20 times. Oh, I took 20 times 4. Yeah, okay. It is divided by 2. This is 40. So it's 40. So now it is 40 plus 30 is 70, 100. So 100 divided by 2, right? So V is 50. Right. Okay. So if it doesn't match correctly, we should verify. Okay. Yeah. So question is simple. There is nothing in the question. We just need to remember this thing. Okay. Area of trapezium. Next question. A body of mass m hits normally. Normally means at perpendiculars. Okay. A rigid wall with velocity v and bounces back with the same velocity. The impulse experienced by the body is, tell me. You have this wall and body hits with some velocity. This is p1, let's say, and comes back with the same velocity, same body. Okay, comes back with same velocity. So this is p1, this is p2. So if velocity is same, can I say that p1 is equal to minus p2? So impulse will be equal to p2 minus p1, right? So I can say p2 is equal to minus p1 or p1 is equal to minus p2 because their direction of velocities are opposite. This is p2 minus minus p2, and that is equal to, you can say, 2 times of p2, 2 times of p. Okay, that is 2 times of mass into velocity, right? So it is option C. Okay, let's see this one. A rigid ball of mass m strikes a rigid wall or at 60 degree and gets reflected without loss of speed as shown in the figure. The value of impulse imparted by the wall on the ball will be. Tell me, what should we do? Only vertical component. Mhm. Okay, let's check. I'm sorry. So you have, let me draw it. So you have this velocity, right? Velocity is in this direction. We can resolve it along two components. So this is mv and this angle is 60. This angle is 60. Okay. So the ball hits the wall at an angle of 30 degrees, you can say, with the wall. Okay. So this angle, so this angle would be how much? 60 degrees. So the horizontal component of the momentum is mv cos of 60, right? The vertical component will be mv sin 60 and it gets reflected like this. So this is horizontal component, this is vertical component. Horizontal component is mv cos of 60, vertical component is mv sin 60. Okay, sin 60. Okay, so there is no change in the vertical component. The vertical component remains as it is. Only the horizontal component of the momentum is changing. Okay, so what can we say? How much is change in momentum? So P2 minus P1 will be equal to just change in horizontal component. Okay, so I can say this is P2x and this is P1x. So it will be just equal to P2x minus P1x. Okay, and that is, if this is positive, this will be negative. Okay, so it is mv cos 60 minus mv cos 60, and therefore answer would be 2 times mv cos of 60, and that is 2 times mv. What is cos 60? Half. Okay, so it is mv. So did you say mv? Okay, good. So was your reasoning like this? The vertical component does not change. Okay, good. Vertical component remains constant. Okay, so no need to consider that. Only the horizontal component is changing. Right. So let's see next question. A 0.5 kg ball moving with a speed of 12 meters per second strikes a hard wall at an angle of 30 degree with the wall. It is reflected with the same speed at same angle. If the ball is in contact with the wall for 0.25 seconds, the average force acting on the wall is. Now tell me. So this is actually same as that of last problem. Can I copy this? No. Okay. Yeah. So problem is actually same as that of the last one. So see, it hits at 30° with the wall. So if you have wall like this, a wall like this, if it hits at 30 degrees, okay, if it hits at 30 degrees with the wall, then how much with the angle with the horizontal? It will be 60 degrees. Okay. So this is actually the same problem, but with values. Okay. With some values. So how much will be change in momentum? P2 minus P1 will be just mv, you can say, right? Yes, no, because angle is also same. Okay, this is striking at an angle of 30° with the wall. This one is also striking at an angle of 30° with the wall. It is reflected with the same speed at same angle. Okay, if the ball is in contact with wall for 0.25 seconds, the average force, in this case we want average force. So P2 minus P1 will be mv, and how much will be the average force then? P2 minus P1 divided by T, mv divided by T, right? So F is equal to mv upon T. So that is, how much is m? 0.5, v is 12, and T is 0.25. So 0.5 upon 0.25 is 2, 2 times 12, 24. Okay, so answer is 24 newtons, right? Okay. Then once again, now a body of mass 3 kg hits a wall at an angle of 60° and returns at the same angle. It returns at the same angle. So the impact time was 0.2 second. The force exerted on the wall is, how much will be the force? So wall is in vertical direction. Okay. So there is only change in the horizontal component, right? So this is px, and this will be, okay, horizontal component. Let's call it px. So how much will be change in momentum? So delta p, change in momentum, is equal to what? 2 times of px, 2 times of horizontal component. Okay. And if this angle is 60 degrees, how much will be this angle? 30 degrees, right? This angle is 30 degrees. So now in this kind of problem, we'll directly say that if wall is vertical, change in momentum will be 2 times of px. If wall is horizontal, okay, a ball hits like this, then change in momentum will be 2 times of py. Okay, so the momentum, component of momentum in direction of the wall remains constant. If it is vertical, py will remain constant. The change is only 2 times px. Okay, so it is equal to 2 times of px is p cos of 30 degrees, because this angle is 30 degrees, right? So p is how much? It is 3 kg, hits the wall at an angle of 60 degree and return at the same angle. The impact time is given. Okay, force exerted on the wall is, oh, but its velocity is not given. Velocity is given here, 10 meters per second. Okay, it's not given here, it's here. Okay, so how much will be force? F is equal to 2 times mv cos 30 divided by time. 2 times 3 multiplied by v is how much? 10 multiplied by cos of 30 is root 3 upon 2, and time is 0.2. So this 2 gets cancelled. It is 3 root 3, 30 root 3 divided by 0.2. Okay, or you can say it will be 150 root 3, right? Option A. Okay. So this is repeated a lot of times. Same question. 1, 2, 3, 4, I can say. There might be more. Okay. All right. So then next, let us see this law. Okay, the law of conservation of momentum. So what is law of conservation of momentum? So now suppose there are two bodies which are colliding. Okay. I'm sorry. Suppose you have this ball. Okay, it's moving on floor with velocity u2. Okay, so you have two balls. Mass of first ball is m1, mass of second ball is m2, and they are moving in a straight line. This one is moving with speed u1, this one is moving with speed u2, and this one collides the second one. In order to this thing, in order that this thing to happen, what should be the condition? u2 is greater or u1 is greater? u1 should be greater, right? Suppose it collides with this body. Okay, now what happens when they collide? The second body will exert force on the first body will exert uh, force on the second body. Okay, and momentum of both bodies will change. So suppose the final velocity of first body is v1, final velocity of second body is v2. So now final momentum of the first body will be m1 v1, final momentum of the second will be m2 v2. Okay, so the law of conservation of momentum says that if we do all this, that two forces will be same, okay, in magnitude, equivalent, opposite in direction, and so force acting on first due to second will be equal to what? Change in momentum of first body divided by time. Okay, so it is m1 multiplied by v1 minus u1 divided by time, and force on second due to the first one is m2 multiplied by v2 minus u2 divided by the time. Okay, so time will get cancelled because time will be equal. Both bodies will be in contact with each other for the same time. Time gets cancelled, and now you get m1 v1 minus u1 equals to minus of m2 v2 minus u2. If you rearrange the terms, you will get m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So what does this mean? The total momentum of these two bodies before collision is equal to total momentum of these two bodies after the collision. Okay, so this is clear. This is law of conservation of momentum, that the total momentum of these bodies will be constant. Okay, now, so there is a question. So if this body, first body hits the second body, its velocity is u1, velocity of second one is u2. So now when they collide, u1 will increase or decrease? u1 will increase or u1 will decrease, and u2 will increase. Okay, all right, so this is conservation of momentum. Okay, so now let's see this problem based upon this. A shell in flight explodes into four unequal parts. Which of the following is conserved? This is momentum, right? Because you have a shell, it explodes into four parts. What will happen? So here it is breaking into four parts because of internal forces only. Okay, there is no external force which is breaking it. That's why we can say momentum of this shell before breaking into four parts and momentum after breaking into four parts should be equal, because it happens due to the internal forces. Okay, and as we see, if we consider these two bodies as one system, then what is net force on this system? So force on first due to second and force on second due to first, it is equal and opposite. So the net force will be 0, right? If we consider these two bodies as one system, then these two forces are considered to be internal forces and they are cancelled out. Okay. So in this case now, if these are four parts, before breaking they were together. So there will be force on first part due to other three, second one due to other three. Okay. But all of these forces are internal forces, right? So internal forces are always cancelled out and therefore net force will be 0. So momentum does not change. So it is option B. Okay. So law of conservation of momentum can be said as for a system, for an isolated system of interacting particles, the net momentum of the system remains conserved. Isolated meaning there is no external force. Okay. So let's see this question. A man fires a bullet of mass 200 gram at speed of 5 meters per second. The gun is of 1 kg mass. By what velocity the gun rebounds backward? So tell me, what should we do? Right. Right. We can say total momentum before the firing is equal to total momentum after firing. Okay. So total momentum, I can say P before firing equals to P after firing. Right. P before firing was 0. P after firing, momentum after firing is equal to momentum of first body plus momentum of second body. Okay. So that is bullet and you have a gun. So momentum of bullet plus momentum of gun, and that is equal to momentum of bullet times mass of bullet times velocity of bullet plus mass of this gun multiplied by velocity of gun, and we want velocity of gun. Okay. So gun's mass is given, that is 1 kg. We want its velocity. So mass of the bullet is 200 gram. It is in gram. It is 200 multiplied by 10 raised to minus 3. And this is speed is 5. So this is simple. Vg will be equal to what? 200 times 5 is 1000. 1000 multiplied by 10 raised to minus 3. Okay. It will be minus of 1 meters per second. Right? Option A. Okay. So questions on the conservation of momentum will be simple questions. So let's see this one. A mass of 1 kg is thrown up with velocity of 100 meters per second. After 5 seconds, it explodes into two parts. One part of mass 400 gram comes down with a velocity of 25 meters per second. The velocity of other part is. What should we do here? Right. So we need to find out momentum before it explodes. Okay. So we are throwing this mass above with the speed of 100 meters per second. Okay. And v will be equal to u minus gt, I can say, because I am throwing it upwards. Okay. So u is upwards, g is downwards. So let's find out v. How much will be v? V is equal to u is 100 minus g is, let's take 10, 10 times 5. So v will be equal to 100 minus 50, 50 meters per second. Okay. And then it explodes into two parts after that. So its velocity is still 50 meters per second going up. Okay, and its mass is 1 kg. So we can say P initial, okay, Pi, let's say, equals to Pf. Pi is equal to what? M into V. If it breaks into two parts, it will be M1 V1 plus M2 V2. So this is 50 times 1, and masses are 400 gram comes down with velocity of 25 meters per second. So what will you consider this velocity, positive or negative? 400 gram comes down. Okay, this one was going up, its velocity was positive. This one comes down, so this velocity is negative, right? Yes, no? Okay, so it's 400 multiplied by 10 raised to minus 3, because this is in grams, or I can just say this is 0.4 kilogram multiplied by its velocity is minus 25. Plus you have m2. M2 is how much? If this was 400, 0.6. 0.6 V2. So let's take this on other side. So it is minus 25 times 0.4. So 25 times 4 is 100. This will be, okay, this will be how much? 10, minus 10. Okay, take it on other side. So it will be 50 minus 10, 40. V2 equals to, sorry, it will be plus 10, no? This is minus 10 on this side. Okay, so 50 plus 10, 60. So 0.6 V2 is 60. That means V2 will be 100. So it is option C. So this is simple, right? Okay, but in this question, we have to find initial momentum. Okay, it is not 0. So students sometimes make this mistake. They take momentum, initial momentum is 0, or they take it as 1 times 100. Okay, because initial velocity is 100, so they will take 1 times 100. It is not 1 times 100, right? So we have to solve for this. Okay, so actually I can say this was good question. Okay, let's see this one. A body of mass 5 kg explodes at rest into 3 fragments with masses in ratio of 1:1:3. The fragments with equal masses fly in mutually perpendicular directions with speeds of 21 meters per second. The velocity of heaviest fragment in meters per second will be. Tell me, what should we do? Yeah. All right. Let us solve this. There is a body which explodes into 3 fragments, 3 pieces. Okay. The fragments with equal masses, 1 and 1, they fly in mutually perpendicular directions with speed of 21 meters per second. Okay. You have this body which breaks into 3 pieces. One goes in this direction, one goes in this direction. So in what direction should the third one go? Should go in this direction, right? Because resultant of these two momenta will be like this. Okay, this will be the resultant, right? So this one should go in this direction. Okay, so this is mass. How much? I can say this is 1. This one is 1. Okay, and they are moving with the speed of 21 meters per second. So V equals to 21 meters per second. For this one, it is also 21 meters per second, right? So how much should be the speed of this? Its mass is 3. So find out resultant momentum of these two. How much will that be? They are moving perpendiculars to each other. Okay, if they are moving perpendiculars to each other, what can I say? How much will be the resultant? Or call this Px, P1. Okay, it is in x direction. This is P2, it's in y direction. What will be resultant of these two? P will be equals to square root of P1 square plus P2 square, right? Okay, so it is equal to square root of mass is 1, 1. Okay, so 21 square plus 21 square, 2 times of 21 square. So it will be 21 root 2. And last one has mass equal to 3. We want its velocity. It is 3 multiplied by, okay, its velocity. Momentum is 3 times velocity. So therefore, we can take this 3 on the other side. What do we get? Therefore, V will be equal to, okay, 7, right? 21 divided by 3 is 7. 7 root 2 is the answer. Option A. Got it? Yes, no? Okay. Let's see another question. A 1 kg stationary bomb is exploded in 3 parts having mass 1 is to 1 is to 3 respectively. Parts having same mass move in perpendicular direction with velocity of 30 meters per second. So this is exactly same as that of last problem. Okay. Then the velocity of bigger part will be. Tell me. It will just change. So this is P1, this is P2. Masses are 1, 1. Okay. So net momentum of these two will be equal to what? So P will be equal to square root of P1 square plus P2 square. That is mass is 1 and 1. Speed now is 30. Let's check. So this 30 square plus 30 square. Okay. So this is equal to 30 root 2. And this is equal to m times v. So m is 3. So 3 times v. No, it is option. Okay, 10 root 2 is the answer. Right. It's option A. Okay. Right. There will be this kind of questions in momentum. Okay, law of conservation of momentum. So remaining questions you try to solve and tell me if you can solve or not. Okay.